Today's video will explain the nested class relation. Hello, I'm James Helfrich. There are several types of class relations, and one of those is a nested class, and this is when one class is defined within another class. Why would someone do this? Mostly because the inner class only makes sense within the context of the outer class. This video will explain how to describe a nested class within a UML class diagram, as well as explain several contexts in which this will be useful. A nested class is a class defined within another class. And there are two parties, the enclosing class and the nested class. A nested class is represented with a solid line and a pinwheel end cap. A nested class can be public, meaning the client can instantiate an object of that type, or it can also be private, meaning only methods within the enclosing class can instantiate an object. The UML class diagram does not allow us to distinguish between them. For an example, imagine the list class in C++'s standard template library. Notice I have two attributes, pHead and pTail. Both of these are type node. So I'm going to have a node class, and it's going to be nested within list. And of course, I can have many different nodes within my list. So it's going to be related by composition where the numerosity is many. Now, in this case, the node class is private, which means only the list class has access to it. But we can't really distinguish public from private in this case. And notice also that this nested class also happens to be related by composition. Therefore, I need two horizontal lines and two end caps to fully represent this relation. Now, the last four attributes are erase, insert, begin, and end, and these utilize an iterator. There is no iterator as a member variable, thus it's not related by composition, but the iterator is a nested class within list, and therefore is related by the pinwheel end cap. And it turns out the iterator class is public, means the client can instantiate a list iterator without even instantiating a list object, but that public versus private is not represented in the UML class diagram. Okay, let's take a look at something far more complicated. I'm going to have a SpaceShip class. And a SpaceShip class is going to say in C++ class SpaceShip, and then I'm going to say private position. So I'm going to have a SpaceShip class, and I'm going to have an attribute position, which is private. Now, this position class is related to SpaceShip by composition, but I can use position in any other context, not even involving a spaceship. Therefore, it's not nested. So I want to make it a nested class when that class doesn't make sense outside the context of the enclosing class, in this case, the spaceship. I'm also going to have an enumeration called type, and this has three possible values, enemy, allied, or unaligned. And I'm also going to have a member variable of type. So in the class diagram, I'm going to have an attribute called type. And so I'm going to have a type enumeration, which has three possible values, enemy, allied, and unaligned. And it's going to be related by composition because I have an attribute of the type, but this type is defined within spaceship. Therefore, this is also a nested class. I'm also going to have a behavior class, which is defined within spaceship, and a p-behavior attribute. So in my class diagram, I'm going to have p-behavior, which is type behavior, and therefore I'm going to have a behavior class. It's going to be related by composition because there's going to be exactly one, but this behavior is defined within spaceship, so it's also related by a nested class. Now, it turns out this behavior is a base class. They're not going to have several different types like attack and runaway and hide, all related by inheritance. I can have a nested class have inheritance as well, no problem there. Now, these two nested class, type and behavior, are nested classes, but they're private nested classes. I'm also going to have a public nested class called shuttle. And this shuttle class is going to be related by nested. Now notice that I'm not going to have a member variable of type shuttle. However, the client can instantiate a spaceship shuttle, and that's because, well, the shuttle is related to the spaceship, but the client may want a shuttle of their own. I'm also going to have another enumeration called status, and this one's happen to be public, and it's going to have flying, sleeping, or dead, and I'm going to have a get status attribute. I'm going to have a get status method, which is going to return a status. And therefore, I'm going to need to have a status enumeration, which has three possible values, flying, sleeping, or dead. Now observe this enumeration is nested because it's defined within the spaceship class, and of course it's public as well, which means the client can instantiate an object of type flying, sleeping, or dead. And it's important for them to have that because notice my get status method is going to return one of these statuses, therefore the client needs to see it, therefore it needs to be public. And of course, this is nested. All right, so when we deal with templates, there's a couple complications we're going to need to talk about. Remember our list class from before. Our list class had two nested classes, my node and my iterator. Now it turns out this list is a template class, therefore I have the T in the upper right-hand corner, and my list node is going to have a member variable of type T. Now notice that I have a type T for my node, even though node itself is not a template class. And why is that? Because it inherits the T from the list class. Okay, let's take a look at an extremely contrived example here. I have a class called enclosing, which is a template class. Notice template class T in C++. And I have a public attribute called data of type T. So if I instantiate an object of type E, I have to specify the template type, enclosing int. And notice e.data equals 42 because enclosing int is a 42. I'm also going to have a nested class called nested1. It's going to have a single public attribute called data1 of type T. How can that be possible? Nested is not a template class. But remember, nested inherits the T from the enclosing class. Therefore, if I instantiate an object enclosing float : nested1 n1, n1.data1 equals 3.14159. In other words, it gets the float from the enclosing class. Okay, let's get really contrived and really crazy here. I have another class called nested2, and it has its own template variable called TT. I have two public attributes, one data2, and data2 is of type T that I inherit from my enclosing class, and data3, which is of type TT, which is my own template variable. Now I'm going to instantiate an object enclosing bool nested2 char. Now, n2.data2 is true because the T comes from the enclosing class's template variable T. n2.data3 is a char because that gets it from the TT attribute, which in this case is a character. You can learn more about nested classes in a nested class section of the Class Diagram 2 chapter of the Software Design textbook.